Combination starters and pump controllers serve distinct purposes in motor control. A combination starter is a device that combines a motor starter and overload protection in a single unit. A pump controller is a specialized device specifically designed to control the operation of pumps, providing features tailored to their unique requirements. Combination starters typically include overloads for motor protection, while pump controllers may or may not have integrated overloads depending on the specific model. The major differences between these devices can be broken down into several key areas. Firstly, pump-specific features. Pump controllers often offer advanced features specifically designed for pump applications such as pressure sensing, flow monitoring, anti-cavitation control, and variable speed control. Secondly, control logic. Combination starters provide basic starting and stopping control. Pump controllers offer more sophisticated control logic, allowing for customized operation based on process parameters. Thirdly, communication capabilities. Pump controllers may have built-in communication protocols such as Modbus or BACnet for remote monitoring and control. Fourthly, diagnostic functions. Pump controllers typically have advanced diagnostic capabilities, providing detailed insights into pump performance and potential issues. Considering a specific application involving two pumps and a diesel backup, a combination starter could be a suitable solution if only basic starting and stopping control is required, separate overload protection is already installed, and pump-specific features or advanced control logic are not needed. However, if a more comprehensive solution with pump-specific features, advanced control, and diagnostic capabilities is desired, a pump controller would be a better choice. This would simplify system design and provide enhanced flexibility and reliability for pump operation. The term pump controller is a specific device category designed for pump applications. However, it is sometimes used as a generic term to refer to any device that controls pumps, including combination starters and programmable logic controllers, also known as PLC. When selecting between a combination starter and a pump controller, several factors need to be considered to ensure the chosen solution meets the specific requirements of the application. These factors include the level of control required, the need for pump-specific features, communication requirements, and diagnostic needs. In applications where basic starting and stopping control is sufficient and pump-specific features are not required, a combination starter can be a cost-effective and reliable solution. Combination starters provide overload protection, which is essential for protecting the motor from damage due to excessive current. They are relatively simple to install and maintain, making them a popular choice for many applications. However, combination starters lack the advanced control capabilities and pump-specific features offered by pump controllers. Pump controllers are designed to provide precise control over pump operation, optimizing performance and efficiency. They offer a range of features such as pressure sensing, flow monitoring, and variable speed control, which can be used to tailor pump operation to specific process requirements. For example, pressure sensing can be used to maintain a constant pressure in the system, while flow monitoring can be used to detect leaks or other problems. Variable speed control allows the pump to be operated at different speeds, reducing energy consumption and extending pump life. In addition to advanced control capabilities, pump controllers also offer communication features that allow for remote monitoring and control. These features can be used to monitor pump performance, diagnose problems, and adjust settings from a central location. Pump controllers also typically have advanced diagnostic capabilities that provide detailed insights into pump performance and potential issues. This information can be used to identify problems early, preventing costly downtime and repairs. When selecting a pump controller, it is important to consider the specific communication protocols and diagnostic features required for the application. Some pump controllers support a variety of communication protocols, such as Modbus, BACnet, and Ethernet, while others are limited to a single protocol. Similarly, some pump controllers offer a comprehensive suite of diagnostic features, while others provide only basic information. Ultimately, the best choice between a combination starter and a pump controller depends on the specific requirements of the application. If basic starting and stopping control is sufficient, a combination starter may be the best option. However, if advanced control capabilities, pump-specific features, or communication and diagnostic capabilities are required, a pump controller is the better choice. In some cases, a hybrid solution may be appropriate. For example, a combination starter could be used in conjunction with a separate pump controller to provide both overload protection and advanced control capabilities. This approach can be particularly useful in applications where the benefits of both types of devices are needed. When designing a pump control system, it is important to carefully consider all of the factors involved and select the solution that best meets the specific requirements of the application. This will help to ensure that the system operates efficiently, reliably, and safely. Several other factors can influence the choice between combination starters and pump controllers. These include the complexity of the system, the level of automation required, and the budget available. More complex systems with high levels of automation often benefit from the advanced features and control capabilities of pump controllers. These systems may also require communication and diagnostic capabilities for remote monitoring and control. However, pump controllers are typically more expensive than combination starters, so budget constraints may limit their use in some applications. Simpler systems with basic control requirements may be adequately served by combination starters, which offer a cost-effective and reliable solution. The physical environment in which the pump control system will be installed can also influence the choice of devices. In harsh environments with high temperatures, humidity, or dust, it is important to select devices that are designed to withstand these conditions. Some combination starters and pump controllers are available with special enclosures that provide protection against environmental factors. The size and weight of the devices can also be a consideration, particularly in applications where space is limited. Combination starters are typically smaller and lighter than pump controllers, making them easier to install in tight spaces. Finally, it is important to consider the availability of qualified personnel to install, maintain, and repair the pump control system. Combination starters are relatively simple to install and maintain, while pump controllers require more specialized knowledge and skills. If qualified personnel are not available, it may be necessary to choose a simpler system that can be easily maintained by existing staff. In summary, the choice between combination starters and pump controllers depends on a variety of factors, including the level of control required, the need for pump-specific features, communication requirements, diagnostic needs, system complexity, automation level, budget constraints, environmental conditions, and availability of qualified personnel. By carefully considering all of these factors, it is possible to select the solution that best meets the specific requirements of the application. Let's delve deeper into the specific features and functionalities that differentiate combination starters and pump controllers, providing a more comprehensive understanding of their respective capabilities. Combination starters, at their core, provide a straightforward means of starting and stopping a motor while offering essential overload protection. The overload protection component is critical, as it safeguards the motor from damage caused by excessive current draw. This excessive current can arise from various scenarios, such as a motor working harder than intended due to a mechanical issue or a voltage imbalance in the power supply. The overload protection typically consists of thermal overload relays or electronic overload relays. Thermal overload relays use a bimetallic strip that bends when heated by the motor's current. If the current exceeds a predetermined threshold, the strip bends enough to trip a contact, interrupting the power supply to the motor. Electronic overload relays, on the other hand, use current transformers to measure the motor's current and a microprocessor to analyze the data. These relays offer more precise and adjustable overload protection settings compared to thermal relays. They can also provide additional features such as undercurrent protection, phase loss protection, and ground fault protection. The simplicity of combination starters makes them easy to install and maintain. They are also relatively inexpensive, making them a cost-effective solution for many basic motor control applications. However, their limited functionality makes them unsuitable for applications requiring advanced control or monitoring capabilities. Pump controllers, in contrast, are designed specifically for the unique demands of pump applications. They offer a wide array of features tailored to optimize pump performance, protect the pump from damage, and integrate seamlessly with other control systems. One of the key features of pump controllers is their ability to monitor and control various process parameters related to pump operation. These parameters may include pressure, flow, level, and temperature. By monitoring these parameters, a pump controller can adjust the pump speed or output to maintain desired set points. For example, in a water distribution system, a pump controller can monitor the pressure in the pipelines and adjust the pump speed to maintain a constant pressure, regardless of changes in demand. Pump controllers also offer advanced protection features to prevent pump damage. These features may include dry run protection, which prevents the pump from running without water, cavitation protection, which prevents the formation of air bubbles in the pump, and overpressure protection, which prevents the pump from operating at excessive pressures. Dry run protection is particularly important for submersible pumps, which rely on the surrounding water to cool the motor. If the pump runs dry, the motor can overheat and fail. Cavitation protection prevents the formation of air bubbles in the pump, which can damage the impeller and reduce pump efficiency. Overpressure protection prevents the pump from operating at excessive pressures, which can damage the pump seals and other components. Many pump controllers also incorporate communication capabilities, allowing them to be integrated with other control systems such as programmable logic controllers, supervisory control and data acquisition, also known as SCADA systems, and built-in management systems, also known as BMS. This integration allows for remote monitoring and control of the pump, as well as data logging and analysis. Pump controllers can communicate using various protocols such as Modbus, BusNet, Ethernet, and Profibus. This allows them to be easily integrated into existing control systems. The diagnostic capabilities of pump controllers are another significant advantage. They can monitor various pump parameters such as motor current, voltage, vibration, and temperature, and provide alerts or alarms if any abnormal conditions are detected. This allows for early detection of potential problems, preventing costly downtime and repairs. Pump controllers can also provide historical data logging, allowing for analysis of pump performance over time. This data can be used to identify trends, optimize pump operation, and predict maintenance needs. In summary, pump controllers offer a comprehensive solution for controlling and protecting pumps in a wide range of applications. Their advanced features, communication capabilities, and diagnostic functions make them a superior choice for applications requiring precise control, reliable operation, and seamless integration with other control systems. The choice between a combination starter and a pump controller ultimately depends on the specific requirements of the application. If basic starting and stopping control with overload protection is sufficient, a combination starter may be the most cost-effective option. However, if advanced control, protection, communication, and diagnostic capabilities are required, a pump controller is the better choice.